We're going to continue with understanding how to use a digital multimeter. So we went over how to measure voltage, how to measure current, and that we have to always look for the straight bar on top of the letter to make sure we are doing DC. If we pay attention and look, there are some curly ones, and that stands for alternating current or AC, and this is not what we are going to be measuring in our lab. So it has to be the straight bar on top of the letter. It is important to understand how to place the multimeter in the circuit to measure specific quantities. So in the case of measuring voltage, the way the multimeter works is represents like a huge infinite value or an infinite resistor, so that when you make the measurement, you only go and put the leads are parallel to the component or that you're trying to read, and it gives you the value of that component. If you're going to measure current, then the value of the multimeter turns into a zero resistance, so that when you place the multimeter in the location you want to measure the current, it reads only the current that goes through it, and it doesn't affect the behavior of the circuit. It is very important to know how to make the measurements. If you're going to make current measurements, you have to make your multimeter part of the circuit. You have to remove the wires and make the current go, or make the multimeter part of your path, so that you can get a reading for current. When we do the lab to measure that, I'll try to explain you. However, with the multi-sim, they have probes, and the probes take care of that for yourself. So this is a disadvantage that we are going to have, not to actually do the measurements. But keep in mind that whenever you measure current, you have to make the multimeter part of the way or the branch that you are making the measurements, or you're taking the measurements for current. If you're measuring the voltage, then you can just be parallel to the branch or to the element that you are measuring. If you are measuring resistance, you can only do parallel measurement as well. Those are easier to make, but for the current it becomes a little bit more challenge. However, I will demonstrate it when we go into the lab tutorial for the multimeter. We used to be analog multimeters. We don't use them anymore. They are very unreliable, so we are not going to even talk about them. So let's move on. Okay, very important definitions. Please go ahead and try to understand that, because they most likely will be part of your test or your quiz, because they are definitions that you have to know. You have to know what a circuit is, what a ampere is, at least what it stands for, what are the units of. What a charge is. A charge, when we think of charge, we think of electron charge, okay? Electron charge, and from previous from previous videos, we defined that the charge of an electron was 1.6 times 10 to the negative 19. So that's something that you should know. It's not required for you to memorize it, but you should know it. You know, it's a fundamental unit that we want to know. We discussed about conductance. So we know that the conductance is, the units are Siemens, and it is 1 over resistance. So if the value of a resistor is huge, or large, we have a small conductance. That means the path of the current, it is very limited. You are squeezing it, so not a lot of currents can go. If the resistance it's a small number, then the conductance is a large number, which means the path for the current is being stretched. So it is an important measurement. Then Coulomb, we define it as being the unit of charge. Current, we said that it was a rate of how many electrons can go through a cross section. We define electron and the Bohr atom model. We define the ground, how every electrical circuit has to have a ground for the voltage to make sense. So voltage is a differential voltage. So voltage is always going to have a reference to what the value is. In our case, we're always going to have the reference as 0 to the value of the voltage. Later, when we start doing nodal analysis toward the end of this class, we will see that our ground is not going to always be our point of reference. So that's important to always understand that the voltage we are dealing with is a differential voltage, a difference between 2 points. So the value we have, it has a reference point. We know ohms, that it was the units of resistance represented by the lowercase omega. Potentiometer, we saw that it is a variable resistor that has 3 terminals. The middle terminal is the one that you can move to take any value between the range of the potentiometer. We saw that resistance is what opposes or fights the flow of current. A electrostat is a type of variable resistor. Siemens are the units for conductance. Volts are the units for voltage. We define voltage. When we do quiz number 2, I want you to solve the problem, use the definition of voltage, which is the work it takes for one charge to be moved across the electrical field. The units are joules over coulomb. And that concludes our chapter 2.